So then where does Kubernetes fit into all of this? Well, Kubernetes is an orchestration engine that allows us to manage our containers and all of the infrastructure that goes in around it. It allows us to manage the container hosts, the networking capabilities, the storage capabilities that are required for all of this infrastructure. Okay? Manages large numbers of containers. It will keep track of each of the containers and we'll say, all right, this application requires 3 different copies of this particular container behind a load balancer. And if one of those containers should fail, then the Kubernetes engine will restart that failed container. Okay? Now, if one of the container hosts should fail, vSphere will kick in with vSphere HA, restart the container host, and then Kubernetes can continue to do its job. Okay? Kubernetes can allow us to scale to meet the capacity requirements for the application by simply saying, hey, I need 6 of these now instead of 3. I just change the number of replicas to 6 of a particular container and let the system run, and new containers will then be deployed by Kubernetes into the environment. Okay? It provides all of the networking as well as all of the load balancing, and along with the networking also comes things like firewalls and so on. So Kubernetes is that orchestration system that allows us to do all of this. It's open source, once again originally developed by VMware, once again developed by Google, okay? But now VMware has brought this in-house as well and integrated these tools directly into vSphere. Now, Kubernetes itself, it's a really big environment. It does so much. And it becomes complicated if we were to take all of these different open source, there are literally hundreds of open source projects that work with Kubernetes, to actually have to choose, okay, what am I going to use? Which open source project am I going to use for my container engine? Which one am I going to use for my container host? Which open source project am I going to use for my repositories for all the containers? And what am I going to do for orchestration? And what am I going to do for networking and security? And what am I going to do for persistent storage when these containers need to save data? How am I going to actually deal with all of this? There are so many different layers to this that it becomes really complicated. So what we need is a one-stop shop to say, hey, hit the button, let's deploy Kubernetes. We'll use all of the tools that come as a part of either vSphere with Kubernetes or Tanzu Kubernetes Grid, which, like I said before, takes Kubernetes and runs it in virtual machines, that's our TKG, versus Kubernetes running natively in the hypervisor, that's vSphere with Kubernetes. Right? Choose one of those two, and it's really a one-stop shop that delivers all of these different systems for us to use. So you can kind of see that there are lots of requirements for particular application, right? For all of those different microservices and all of the different policies that are required by those in terms of security and load balancing and storage and collecting metrics for these applications and making sure that they're available in multiple locations. All of these sorts of things are managed by Kubernetes that can now run on top of VMware components like vSphere to handle the server virtualization component of it, like NSX to handle the networking components of all of this, like the like data stores through either VMFS data stores or vSAN data stores that can help us to build persistent volumes that can individually be managed so that if our containers need to do things beyond just logging and are actually storing data outside of databases, for example, that we actually have the ability to save that data as well. Okay? like Wavefront, which is another VMware component that allows us to help with the application metrics. All of this stuff is now managed with VMware components. So, if you are asked to manage containers, or if you are asked to implement Kubernetes, at least now, after having seen a little bit of this, we understand some of the terminology and know where vSphere can fit into all of this. So I hope that this was helpful for you. Okay, we don't have a lab around this. It's just designed to help you get an idea as to what some of this language means and what some of the terminology is, to help you understand what we might be working with as we implement containers and DevOps and Kubernetes in our infrastructure. If you want to dive a little bit deeper, VMware has another course on vSphere with Kubernetes coming very soon. Right? I'm recording this in May of 2020, right? And we should have that course available within a month or so. So what are the use cases of all of this stuff now that we have talked about here in Module 3, be it containers or virtual machines? Well, we know that we are going to be asked to run applications, right? That's the number one thing, the most important thing that we could be doing in our environment. And we want to start building virtual machines with different configurations to handle different types of environments. So we know now that vSphere 7, ESXi version 7, allows us lots of different options as we build our virtual machines. Okay? We're going to have the choices of the guest operating system that we want. We're going to know a little something about the applications that we're deploying. And knowing all of that gives us the whole world of the virtual hardware complements that we can add to these virtual machines. So being smart about the requirements of the application will allow us to be smart about the virtual machine that we create in order to satisfy the resource requirements of that particular application. We've got a lot of choices now when it comes to building our virtual machines and the hardware that we place in it. From our storage controllers, choosing the right storage controllers so that we've got a driver ready for the operating system. Using the VMX-Net 3 network adapter so that we can most efficiently make use of the physical networking capabilities of our ESXi hosts. To choosing a virtual GPU, if that's something that we have the hardware capability to choose and that our applications require GPU, we know that we have the ability to do that as well. And that vSphere itself provides the entire underlying infrastructure on which Kubernetes can run, as well as just our virtual machines can run, right? So making sure that we have all the latest and greatest components and that we keep them up and running nicely will give us all of the opportunity to build virtual machines around that. So that does it here for Module 3, right? We understand about virtual machines. Just a set of files that are encapsulated into a folder and placed on a data store. Okay? And we can build virtual machines using our vSphere client, right? Which we know is that HTML5 interface that runs in vCenter, okay? Or our host system, our host client. Okay? We know that we need to install VMware tools as soon as we get the guest operating system installed. We also know about the virtual hardware version, that virtual motherboard whose capabilities increase with each subsequent version of ESXi. And that if we want to run a virtual machine on an older version of ESXi, we might choose an older version of the virtual machine hardware so that that VM itself is most portable between older and newer versions of ESXi. And we understand, of course, about that container technology that is ideal to run microservices and then to be orchestrated by Kubernetes. Well, I hope you've enjoyed this module on virtual machines and containers. And when we come back, we'll look at Module 4 at vCenter.